Thanks, Adam. So my section is titled Data Transformation, and if you thought digital transformation was a buzzword, let's go for data transformation. So when I think about data transformation, what I'm imagining is sort of going the next step beyond the digital transformation. If you think about digital transformation from the standpoint of how we are transforming our sort of our IT strategy in order to, basically modernize it, bring it up to what are we doing today, our data transformation aspect is the next level on top of that. What we're actually doing with the data and on a day-to-day basis, how are we using that to transform the work that we're doing? So I'm going to stick with just three main trends today, and we'll go through these one by one. The first one I want to talk about is data flow automation. Now, I apologize if you feel like I'm leading off with probably the most boring topic in existence, moving data from point to point. But I lead off with this because it's still super important. We're seeing consistently that when we talk to scientists as part of our assessments and the work we're doing with our clients, they spend a substantial amount of time just simply moving data from system to system. They've got it on their instrument, it needs to go to their laptop, they put it on a thumb drive, they cut and paste from one proprietary application to their Excel spreadsheet. And this is sort of ironic if you think about it because like computers are good at moving data. That's how they've been designed, right? So how can we overcome these hurdles? How can we make our computers do the work for us so that we can focus on the most important aspects of the job that we have in front of us? Part of the challenge with data today is that there's just this explosion of proprietary or custom or changing data formats, right? Data is being generated by people, and it's being handwritten on pieces of paper that are scanned in, and then that data all needs to come into your system. Today I'm going to be talking a little bit about some of the projects that we've had going on recently, and the project I want to highlight today is one that we've been doing with a mid-sized pharma company. They identified this as part of their data transformation strategy, as a core element of their strategy. They needed to be able to increase the level of automation about moving data from the data producers downstream towards the data consumers. So this involved, taking this data, making it available in searchable, raw, and processed formats. But the remarkable thing about it was the number of different sources that they had. They didn't just have, one or two or three instruments that they were trying to cover. They were trying to cover dozens of instrument types. Again, many with these proprietary or custom formats. Now, a system like this needs to have some sort of a data processing component, right? You got to take the data, reformat it, and push it to the outside. But as you think through the design and implementation of the system, one of the big concerns was how complex is this going to end up being, right? You've got so many data flows. How are you going to be able to handle them and not overburden your data engineering team in terms of the constant management of that? And I want to leave you with two key takeaways on this trend. First of all, of course, is there's a tendency to try to think like, okay, well, we've got these custom sources, we've got these custom flows, let's just build a custom infrastructure to do that. And the challenge, of course, is that the more that you have custom, the more that you have to support. And so I strongly advocate for pulling off-the-shelf tooling as much as possible. Even if your workflows have custom components as part of them, the more you can bring off-the-shelf tooling in, the faster you're going to be able to go. And there are plenty of vendors out there, I've talked to many of them, that solve particular points in the process, and you just have to be a little crafty about how that's going to fit in with your overall architecture. But in line with that, there's sort of this broader balance of balancing custom components and off-the-shelf tooling with your organizational complexity or capacity. And this goes to what Adam just mentioned before. You don't necessarily want to go towards a highly automated, highly custom solution just because you see, the largest or the most, from your perspective, maybe the most successful organizations doing that, they may be able to throw inordinate amounts of human or financial resources at the problem. You may find it more appropriate to level down on your automation or your sophistication in order to keep it tractable within your organization. So just consider that as a very sort of cautious three-way balance. Now I want to spend a few minutes talking about data commons. So if you haven't heard the buzzword of data commons, I'll cover it really briefly. A data commons is fundamentally the notion of bringing data together. Now, we've obviously been bringing data together for quite a long time, but the most important part of the word data commons is the commons part, because a data commons fundamentally is not just about bringing data together, but it's about bringing multiple user communities to the same place to promote the idea of data sharing and reduce the amount of data siloing. So it's not just a database or a data lake, it's actually a place where lots of different parts of your organization or organizations that you're interacting with can be in one sort of data environment. And there's lots to unpack about data commons that I don't have the time to cover right now. I want to drill in today to talk about how you would build it, and basically like what resources, what building blocks, what tools you might want to build out, what you might want to use to build it. And there's even just in this one axis, there's a ton of options, right? You can go with an off-the-shelf system like Gen 3. You can build it like a data lake, but build it sort of commons oriented and use those market standard components, but assemble them to achieve your organizational goals. Or again, you can scratch build that, right? If there's particular flexibility or particular features that you need, you can go along that road. And just I emphasize this is a highly nonlinear and multi-factor decision. It's not a one-size-fits-all, across organizations or even within your organization. So I'll talk a little bit about a project that we've had going on for a couple of years now with Bristol-Myers Squibb. So they've worked with us, and we've collaborated on designing a data common system for their organization that was specifically designed to break down silos between parts of their organization and bring data together with a common cloud workspace, a common SDK, so that these teams could share data much more easily. And an interesting lesson learned, so they started with an off-the-shelf platform in Gen 3, and they've actually been evolving their system to include more and more custom components as it aligns with their organizational goals. And for the takeaways here, I want to leave you with, as you design out this data commons, one thing that's become abundantly clear to us is that commons is not a fixed thing by any stretch of the imagination. It's going to change its focus and it's going to evolve over time. And this is actually maybe a little bit obvious. You can't just like deploy a data commons and have it instantly be available to everybody. You're going to onboard different parts of your organization to that over time. But also your organization is going to change. And so this means changes to the formats of data or the schema or the interaction methods, right? Similar to that, because the point of a data commons is to have multiple user communities coming together, those user communities will all have their own interests and skill levels and engagement model with this commons platform. And so as you're designing it out, be prepared for the possibility that you may have custom portals or custom workflows for specific user communities. Just because it's a common platform doesn't mean that everybody has to have the same boring, one-size-fits-all interface. It can be tailored to the needs, and the day-to-day working behaviors and practices of individual parts of that overarching community. And just to close out, the last trend I want to talk about is about fair data. Apologize for the visual pun. So if you haven't heard about this buzzword, this is an acronym standing for Findable, Accessible, Interoperable, and Reusable Data. Fair data, I think, is an excellent guiding star for data-centric designs where your goal is to basically build a data system and have it be the most useful possible, not just for its current consumers today, but for unknown and potential future consumers of that data system. Now, one sly thing that may not always come across for people who are talking about fair data is that those 4 goals are not necessarily all the same difficulty in terms of implementation. And from my take, they actually sort of get harder as you go along the acronym. So just being able to find something can still be a challenge, but it's probably the easiest thing. But going all the way to the reusable case can get quite challenging. And today, pardon me, I want to talk about the interoperable aspect of this, because I believe that the interoperability of data is challenging, but it's also the thing that we have the most chance of being tractable in our technical solutions. And to review this, I want to talk about the work we've been doing with the NHLBI and Biodata Catalyst. So NHLBI is the National Heart, Lung, and Blood Institute as part of the National Institutes of Health. It's one of the largest institutes in the NIH. And they've been building a data commons called Biodata Catalyst to support the use of data from TopMed and other heart, lung, blood research studies. When they initially designed Biodata Catalyst several years ago, they baked in interoperability as one of its guiding principles. And it's proven to have kind of very interesting consequences as part of the overall architecture, which I don't want to unpack too much, but I do want to call it out because for that organization to set it out as a goal, they've had to strive towards things and almost lead the edge, especially participating in this NCPI, NIH Cloud Platform interoperability effort. Interoperability is not necessarily something that happens naturally. You actually have to pursue it. And in order to pursue interoperability and try to gain at least one of those 4 bullet points from your FAIR scorecard, I have 2 key takeaways. And they both revolve around the notion of standards. And I say standards because if you focus on the definition of interoperability is all about 2 or more systems working together. If those 2 systems are working together, they have to have a common language. They have to have a common reference point, which means that there has to be some form of standard between those 2. Which means that as we design and build data systems that are oriented towards the FAIR data principles, we have to be looking for and implementing standards in our systems. And that's not necessarily a straightforward thing. You may not know about the existence of standards in your particular field of practice. GA4GH, Adam called out earlier, and I've called out some of their standards or their toolkits on this slide. There's a wealth of information just available there if you're working in these particular spaces. So point number 1, of course, is to just use those standards. But I would go even so far as to say that recognize that you may be working with vendors who may not have standards implemented. You need to ask them sometimes to implement certain standards. You may have read about a GA4GH standard or a data storage standard for your particular area. If we're not asking our vendors to implement the standards, they're not necessarily going to just do it out of the goodness of their own hearts. And so by pushing standards forward from the perspective of community request and community adoption, I think we'll be able to push ourselves even farther forward towards interoperability.